Hello, everyone, and welcome to our exciting session on enhancing high performance computing with software defined networking. I am very happy to be here and I'm very excited to kick off this discussion. In case this is your first time hearing about us, and before we dive into the technical brilliance of our talk, let me introduce you to Morocco HPC. So, our initiative is actually all about pushing the boundaries of high performance computing in Morocco, supporting innovation, and empowering brilliant minds across research and industry. So we try to do that by hosting a number of events, namely our webinar series, which you are currently attending. And we really work towards providing a platform to share ideas and expertise about HPC. Today, we are very honored to have Dr. Najm Naji with us. And I am personally happy to have Najm with us here today because he is an old colleague, an old lab mate, and an old friend. So I was very happy when he accepted my invitation. So Najm is an expert in networking and technology, and as a curriculum designer, R&D consultant, and network engineer with expertise in IoT, smart buildings, distributed systems, energy efficiency, and HVAC system optimization. He is really the one to talk to you about how software-defined networking is really revolutionizing HPC by making our systems more agile, scalable, and efficient. So, Najm, thank you very much for accepting the invitation, and we're really happy to have you here with us. And yeah, the floor is yours.
Thank you so much, Dr. Safa, first of all, for the invitation. I'm so much happy to get back in touch with you in a professional way, and in this given this talk about enhancing high performance or HPC using SDN. Yeah, so in today's lecture, I will be talking on how do SDN do enable the HPC get better for computational purposes. We know that HPC relies on really high-tech architecture and high-tech hardware. So in today, what we are going to do is that we will see how do SDN allows HPC applications talk to the underlying infrastructure, hardware infrastructure. Okay, so we know that HPC is there in order to process large amounts of data, enables AI, artificial intelligence, and it's there to process data coming from different IoT, millions and billions of IoT devices. Hence, it do require a lot of computation power. So therefore, HPC do really rely on the underlying hardware infrastructure. So that's why in today's lecture, we will try to answer 3 questions. Basically, the first one, what are the network infrastructure challenges for high performance computing? And from that, we will start defining what is software defined networking. And the third question we're trying to answer is how can SDN help overcoming the infrastructure challenges in HPC? So first of all, what are the network infrastructure challenges for high performance computing? So with the processing of large data, of course, we need to transfer large amounts of data. Hence, we need increasing bandwidth demand from users and also from the computational nodes. So with that, we may have a lot of latency when transferring data between the different nodes or from the end nodes to the controller or the head clusters. And also we need to, in HPC, we need to have the ability of scalability. So we need to be able to scale rapidly. So the underlying infrastructure should allow the plug and play devices and computation nodes. So these are the challenges that we do have in the HPC. We also have some challenges related to having the heterogeneous underlying hardware. So different hardware with different configurations and brands and manufacturers and architectures. So we need to manage that. And these are one of the challenges. One of the challenges we do have in the underlying infrastructure is that from time to time, we need to perform manual configuration, okay, of the different underlying computational nodes or head clusters or controllers, etc. So this manual configuration do really consume time. From the upper perspective, we have a lack of visibility, or we do have a limited visibility about the underlying status of the infrastructure. Hence, we need to have a clear vision, or allow applications and the one using the underlying infrastructure to have a clear vision or visibility about what is going on real time on the underlying infrastructure. Also, one of the challenges that we do have is that we don't know how to allocate resources. So allocating resources real time is basically based on the status of the underlying infrastructure. And also what we do need to tackle as challenges in HPC is that we need to have the fault tolerance. So we can't do this if we don't have really a clear vision, okay, about the underlying infrastructure. So with regards to these challenges, we will now these are some of the challenges that we do have. Now we'll talk about the SDN. What is SDN? So basically, SDN is a new way of managing the network. So it's called software-defined network, and it is basically based on separating two things. So we try to separate what we call it the data plane from the control plane. So in the traditional network management that we do, we have both data plane and control plane at the same device, which means that the device that do transfer the data or transfer the data flow or the packet flow is the one managing how to do these things, okay? So in one single node, as we can see, for instance, here, we can have both. So the data plane and the control plane are at the same node, okay? So we have, for instance, here the switch, and this is another node considered as a switch, and this is as a switch or a router. So we have both parts, control plane and data plane, are at the same node. Whereas when we move to the SDN, we have only the data plane at the level of the nodes, and these nodes are programmable, which means we can configure them. But now we do not do that manually, but we do it through an SDN controller. Okay. Now you might ask the question, this is kind of a simple management, but what I'm going to tell you is that now the SDN is not there for the network administrator, but it is there also for the application itself. So the SDN is there to communicate with the application, since the application can talk to the underlying infrastructure and take control, depending on the need. Okay, so it is known that the data plane implements forwarding functionality, okay, whereas that we talked about the control plane is a centralized node. So in the control plane, we have the different algorithms used to program the data plane reside in the control plane. So the control plane is the one that is programming the data plane. So this is basically the simple definition. Now, how this paradigm, or how can SDN help in overcoming HPC networking challenges? So to overcome the networking challenges, we need to talk about the SDN advantages, okay? So the SDN advantages allow us to overcome the challenges through what? Through the flexibility of SDN, to the agility, extensibility, and so on. So the different advantages of SDN do really meet the challenges, or allow us to overcome the challenges of HPC. So one of the challenges that we talked about is heterogeneous hardware. Now with SDN, we can manage different hardware architectures, and we can do also dynamics, what we call it dynamic network configuration. So this was one of the challenges that we do have in HPC, is that we need from time to time to have manual configuration of the hardware. Now we can do that dynamically. One of the things that we're missing in the HPC is that we don't have a clear vision. We don't have a centralized control of the underlying infrastructure. Now with SDN, we have a centralized control that we talked about, the control plane. The SDN allows for scalability. Why? Because it gives us a clear vision about the status of the underlying infrastructure. In addition, it allows us the automation, okay? So in the SDN operations, we have 3 layers. that we are going to talk about today. So we have the SDN switches, which is the underlying layer. On top of it, we have the controller. And on top of that, we have the applications. Now, what are the applications? These are the applications that we do run on top of HPC. Okay, so any application that requires high performance computing is the one that we are talking about it here. Now, what happens is that in the underlying, what we call it southbound, we have the different nodes, which are the routers, the switches, etc. So these nodes, as we have seen earlier, what do they do implement? They do implement what we call it the data plane. But in order to implement what we call the control plane, we need to interact with the SDN controller. Why? Because in the SDN controller, we have the set of rules, we have the set of configurations and policies that we would like to forward, which means these nodes do take decisions, but decisions are not there during the configuration process, but they are communicated from the SDN controller. Now, the SDN controller itself does not only talk to the underlying nodes, but also talk to the upper layer, which are the applications. Now, it talks to the applications through APIs in order to allow the applications themselves to interact with the underlying infrastructure and take decision, for instance, about routing data. So routing is not only now taken from the perspective of the network layer, but also from the application perspective, hence improving performance. We will a bit dig deep into what we call it the controller. So in the controller, what do we have here as an example in the underlying infrastructure? We have the OpenFlow, and as SDN, we can have Open vSwitch. Okay, so what do we have here? We have the OpenFlow at the level of the underlying hardware layer. So what is the role of the OpenFlow? The OpenFlow is a software that allows the controller, which is the Open vSwitch as an example, to communicate with the hardware. Okay, so here what we have three different parts. These are the applications that we talked about, and we have the northbound, which are the APIs through which the distributed core, which is the control plane or the vSwitch, do talk about with the application. So through this northbound, and through the southbound, it does talk to the or communicate to the underlying hardware infrastructure in order what? To discover newly added devices, okay, to observe, program, or configure these devices automatically. Now here we have the applications. As I said, the applications that we talk about here are any application that needs HPC or that we ask HPC or to run, or that requires HPC to be run. These applications are the one that can communicate to the underlying infrastructure through the SDN. So we talk also about flow tables. So flow tables are tables that are in the data plane or the devices in the underlying infrastructure or layer. And these flow tables contains what? Contains the rules through which or through which that the data should be processed or followed. But these flow tables are not nowadays configured manually by an administrator or remotely by an administrator, but the data flow tables are also filled and configured by the applications themselves based on the need. So for instance, here is a scenario. So this topology consists of the Open Network Operating System. So for instance, ONOS. So ONOS is an operating system that can deem as a controller also. And we have an Open vSwitch that manages the switches. So we have here the ONOS controller, and we have here the the switch nodes. So what's the role of the ONOS? The ONOS help us what? Help us figure out what are the connected devices in our network, okay? Hence, we can decide the set of rules that through which we would like to forward the data and communicate these APIs to the applications in order to consume these APIs by the applications. So to summarize, so we talked here about 3 layers in SDN. We talked about the underlying layer, which is the data plane, the core plane, the control plane, and the application. So what's the difference now is that applications themselves do configure and do manage the underlying network infrastructure. So now if you have any questions, you are welcome.
Thank you very much, Najm, for this presentation. Thank you for putting a lot of details, a lot of technical knowledge, and make it very concise and very straight to the point. I would like to ask the audience, if you have any questions, please type them into the chat, and we will take them one by one. All right, so waiting for the audience to put in their questions, I have a quick question for you. So one of the main issues that we have when we talk about HPC, especially when we talk about clusters, like whenever we have a distributed system or we talk about a cluster of computers, sometimes, so we basically use this cluster because we want to have like better efficiency or like a better performance, mainly, not really efficiency, but better performance. But sometimes part of the performance is lost in what we call network overhead. Yeah. So yeah, so like we try to gain in performance, but part of it just goes in the communication, it goes in the network overhead. So is this something that can be like solved using SDNs?
Yes, exactly. So at the first time, it might appear that adding the SDN layer will add an overhead to the network. But that's not the case. Why? Because basically we add that layer in order what? In order to make the application talks directly to the underlying hardware.
Okay.
That is overcoming the network, the traditional network overhead that we do have, which means the decision about whether to forward data to this direction or into this direction. Now it's not done at the level, at the network layer through processing the packets, etc. But it is already mandated by what? Mandated by the software or the application itself. Now, the application itself, how does it take the decision? Because it has a clear visibility about what's going on in the whole network. Through what? Through the SDN itself. So the application, what happens? That the application has a clear vision about what is going on the network. It knows what are the nodes that do have possibility to process more data. What are the nodes that don't have really that much processing power, and it decides upon that. And when it decides upon that, it implies what route this data should go through. Okay. And it does do that in a dynamic way. So it's kind of, we added a layer that might appear as an overhead at the first time, but once we dig into the role of this layer, it just makes the route open wide for the application layer to talk directly to the underlying layer without going through the network overhead or the traditional networking overhead.
Okay, yeah, that makes sense. Yeah, because as you said, whenever we hear there's a new layer introduced, there's always a concern if we're going to lose performance, which is why we're actually doing HPC, because we want to have more performance. What about security? Because again, when we add another layer, it's like we are making our system like more open to attacks. I'm not sure. So yeah, that's my question. Like, how does it deal with security?
Okay, how does it deal with security? First security issue that we need to talk about is the configuration of the different nodes. So when configuring different nodes, remotely or allow for configuring nodes remotely, that's an issue. It's not like we will allow only for configuring nodes. We connect directly to the switch or to the router in order to configure it. But once we have remote access, that raises an issue. Um, one of the security issues that we do have is that if the application itself is vulnerable, d'accord? So what happens is that if I have access to the application, I can consume the APIs in a way that does not serve the application, but actually that does disturb the network itself. So the main vulnerability in this case, it's not just the SDN layer, but the application themselves, because now the applications are not just running in a separate environment, but they do have access to really important resources, not only in one single node, but to the whole underlying infrastructure. So running an application that is not secure is giving the floor to any attacker that can have access to the application to have access not to one single node and not to the node itself, but to managing the whole network.
Okay.
So there is a big concern there, yes, in terms of security. But yeah, it always comes with there's always a trade-off. So we will allow applications themselves to have access and to choose whether to be executed, where to forward the packets, etc. But these applications themselves should be really secured. That's one part. The second part of the security is the SDN layer itself. So the SDN layer itself, in order to communicate with the different nodes, the nodes themselves, as we said in one slide earlier, we said that what we have is that one of the advantages is that it manages different or heterogeneous hardware devices, but the fact that it can interact with these different heterogeneous devices or hardware means that this hardware, if one of these hardware is really vulnerable, we might faces a security issue. So as we said, since it can manage different hardware, we need to pay attention to what kind of hardware we do have, which means having a hardware that is based, and we can call it by default, it has a cloud security, which means by default we don't have access to anything, which means by default deny everything and allow only what we would like to allow, and compared to another device that is by default allowing for everything, and we start denying. So this device, if someone has access to this device, it can have access to what? To SDN. So why? Because the network, the device itself do talk to the SDN controller. Now, from the control perspective, what is the risk? Is that we can configure. So if the attacker has access to the controller, it can configure the node. Now, what if the attacker do have to a vulnerable equipment or a device at the underlying layer? Which means since each node do report its status to the control node, which means I can modify the status that I'm going to communicate. Okay, so I can have access to this node. I use it for my personal computation purposes, but for its own status, I will always tell the control that this node is busy, whereas it is busy with my own computation need, and I report that it's busy. So from different perspectives, there are different security issues that should be taken into consideration. As I said, from the underlying layer, okay, we need to know what kind of hardware we do use, what are the vulnerabilities of this hardware, because now the hardware do talk to, send reports to the SDN controller, and based on this report, the SDN will take decision, and the application itself will take decision. The second thing is that the vulnerability can come from the upper layer, which is the application. So we need to make sure that the application itself is secure, okay, and is not really accessible, because once we modify in it, it can has access to
Okay.
the underlying network. And this also, besides the different vulnerabilities that we might have in different solutions
Okay.
of the control node. Because in the control node, we have different solutions, for instance, ONOS. In the underlying layer, uh, the data plane layer, we have different solutions, such as, for instance, Open vSwitch. So we need to really investigate these two things.
Okay, yeah. Okay, perfect. Thank you. Our audience, I don't know if you have any questions for Dr. Najm. I have another question.
Yeah, sure.
Do you know of any like real world supercomputers or clusters that use software defined networking?
Real world implementation that do use SDN. I believe that most of them nowadays use SDN.
Okay.
It's really rare when we do have really big computing infrastructure that does not use SDN. Why? Because SDN allows for improving performance, allows for visibility, etc. So this mainly increases the response time. So because response time is really one of the critical issues in HPC, SDN is a must that should be used.
Okay, perfect. Thank you so much. That makes sense. I think your presentation was actually very clear that the audience, they do not have any questions for you. But anyways, the webinar will be still on YouTube. So if people just go through it and then they have questions, they can of course go back to you and ask you on LinkedIn, or if you would like to provide any contact
Yeah.
details, that would also be amazing. But yes, thank you very much, Najm, for being here. It was really it's really a pleasure, and it was really interesting to follow with you the talk. Thank you very much.
Thank you, Dr. Safa, for the invite. Thank you for the opportunity to help advance HPC in Morocco. I'm so much happy to give to try to answer these very basic questions, three questions. We do. I believe that we can have other lectures to dig into the details of the SDN, how it can enable HPC. I do still remember from the Solarium Lab at a time when we worked together on different projects,
Yes.
and each time we needed to set up the network, etc. Now I believe that the next step is that we can work on implementing SDN in HPC, and there we can address different research questions, such as security, such as compatibility, integration, etc. Yeah, so that's it. So whenever you need any help with regards to SDN or networking, etc., I believe that we need to we can give a lecture. Other thing is that with the emerging IoT devices and connecting millions and billions of devices, I believe that SDN is the solution. Why? Because it will connect the millions and billions of devices, and we will have a clear vision. Now, of course, the application is the one knowing the real context. Okay, the application is knowing the real context, which means the application itself, on real time, it knows how much processing, how much data it needs to process, hence how much processing power it needs. Hence, it can directly to decide on which node it can execute. So, since we have millions and billions of devices, if we connect them through SDN, we will allow applications to interact directly with the underlying infrastructure without the intervention of the human being, which will really raise the latency of the response time.
Yeah. Yeah, definitely. I think IoT is like a good, maybe like a ground for SDN to perform properly. All right. Some people in the audience are thanking you for the presentation, and I would like to thank you again for joining us today. I'd like to thank the audience for also being with us. And again, as I mentioned, the webinar will be uploaded on YouTube. And if you have any questions, I'm pretty sure Najim will be happy to answer them if you reach out to him.
You're welcome, for sure.
Okay, perfect. Thank you very much.
Thank you,
And
Safa. Thank you, everyone.
thank you. Have a great weekend, everyone.
Thanks, everyone.
Goodbye.
Bye-bye.